How to read electrical diagrams. Unit 18, Timers in Control Systems. Timers and timing charts. Many industrial processes require a timed control sequence. Timed sequences can be initiated during the startup of loads such as motors, heaters, and lighting. Timed sequences can also be initiated during the shutdown of electrical loads such as large blowers, pumps, exhaust fans, generators, and HVAC equipment. There are various types of timers used in control systems. Some timers may have large displays, and others may only contain LEDs for indication of timer status. Timers may plug into a relay-based socket or clip onto a mounting rail. Timer documentation shows device pin numbers for the coil, the contacts, and a control contact or input signal connection. This input signal connection is used as a trigger or activation for various timing functions. The input signal connection is not always used. The timer shown is a rail-mounted multifunction unit that operates on various AC and DC voltages. A schematic diagram of the timer is shown, and a physical layout and wiring diagram is also shown. The relay contact shown is referred to as a changeover contact. It has one common connection, a normally closed contact and a normally open contact connection. Timers in schematic sets. Whatever type of timer is used in a schematic set, the following rules always apply. There must be a coil that is energized constantly or only during the timing process. This rule is dependent on the type of timing function used. There must be at least one set of contacts that are controlled by the timer. The contacts may be normally open, normally closed, or the changeover type, with a common pin and normally open and normally closed connection. A control contact or input signal that activates a timing function may be used. In this case, the timer coil is energized at all times and the timing function is controlled by applying a voltage to a specific pin on the timer. Usually this pin is called a control contact. Timing functions. Numerous timing functions are available. The function is selected by rotating a small selector switch to match the required function. Selector switches are also used to select the timing range and time duration. Numerous timing functions are available, such as on delay, off delay, on-off delay, symmetrical and asynchronous flashers, one-shot, interval, timing after pulse, and many more. Common timing functions. The two most widely used timing functions are on delay and off delay. Timing charts. Timing charts are used to graphically depict the operational relationship between the coil, the control contact, and the timer relay contacts for each timing function. Study the timing chart displayed. Note the coil voltage supply labeled U and color blue. Note the control contact labeled Y and color blue. Now note the relay contact labeled R and color green. Now visualize the real-world physical components with the assignments in the timing chart. A change of component state is represented by the horizontal rectangle state, low or high. Let us study the two most common functions, on delay and off delay. The on delay function does not use a control contact. Notice the Y1 horizontal bar is grayed out. When voltage is applied to the timer coil, the on delay function starts. Once a set time has elapsed, the timer contacts change state. The contacts remain in this state until the coil is de-energized. Once the coil is de-energized, the contacts revert to their shelf state and the process can start over. The letter T and the horizontal arrow show the delayed action of the contacts. An example of on delay is delaying the action of a float switch to prevent contact bouncing and to prevent pump short cycling. Note the pumping chamber, the normally open float switch, and the submersible pump. Smart Relay simulation software is used to demonstrate operation of the circuit. Switch I1 is the normally open float switch. T1 is the timer, and Q1 controls the pump. When the float switch is continuously toggled, the pump does not start. The float must be active for a set time before the pump operates. In this case, the timer is set for an on delay of 3 seconds. When the float switch drops, the timer deactivates the pump instantly. Now let us study the off delay function. The timer coil must be energized and the control contact must be activated for the off delay function to operate. When the control contact is energized, the relay contacts change state instantly. The contacts remain in this state as long as the control contact is energized. When the control contact is de-energized, the off delay time starts. When the off delay time has elapsed, the contacts revert to their shelf state. The important point to note in off delay is that the relay contacts change state instantly when the control contact is energized, and revert to their shelf state when the control contact is de-energized and the time has elapsed. An example of using an off delay timer is controlling a ventilation blower in a welding booth. The ventilation blower operates for a set time after the switch is turned off. This ensures that all welding fumes are purged from the booth. An on-off switch is connected to the control contact of a timer. The timer contacts control the starting and stopping of a ventilation blower. Smart relay simulation software is used to demonstrate operation of the circuit. When the switch is activated, the blower immediately turns on. When the switch is deactivated, the blower remains on for the duration of time set on the timer. Once the time off duration has elapsed, the blower shuts down. Programmable logic controllers and smart relays. If a system contains a controller such as a PLC or smart relay, timing functions will be programmed and executed by this controller. The smart relay in this video can have up to 28 timers programmed, each with its own function. PLCs can contain hundreds of timers. This smart relay has 11 different timing functions. Notice that the timing charts change when a different function is selected. You can test your program by using a built-in simulator. It is a great way to know that the right timing function is used and a great way to learn about timers. Pneumatic timers. Reduced motor starting systems sometimes employ pneumatic timers to control the motor starting sequence. These timers are mechanically fastened to motor starting contactors and operate when the starter is pulled in. No separate control voltage is required for this timer, which is a positive in this case. Pneumatic timers are only available in on delay and off delay. Timer instantaneous relay contacts. These contacts operate as soon as power is supplied to the timer coil, regardless of the type of timing function selected. Timers with 2 or more sets of contacts usually provide this option. Instantaneous contacts could be used to start a control step before time contacts are required, therefore not requiring a normal control relay. IEC and NEMA timer schematic symbols. Shown is the latest version of IEC symbols for the on delay and off delay timers. The on delay contact symbol is intuitive. The contact changes state after the delay time has elapsed. The off delay is less intuitive. When reading a diagram with off delay contacts, you must note that the contacts change state as soon as the coil and control signal is energized. The off delay contacts change back to their original state when the control signal is de-energized and the off delay time has elapsed. Spend some time and study the table of symbols. Now shown is a table of NEMA timer symbols. Note the coil labeled TR. The timer contacts contain an intuitive arrow that shows the action of the contact after the on delay or off delay time has elapsed. Note the acronym beside each symbol. On delay, normally open is normally open, timed closed. Normally closed is normally closed, timed open. Off delay, normally open is normally open, timed open. Normally closed is normally closed, timed closed. Spend some time and study the table of symbols. Remember, the arrows show contact action after the time function has elapsed. Summary: numerous timers and timing functions are available for use in industrial control systems. Multifunction timers can be set up for many different timing functions. The two most common timing functions are on delay and off delay. Timing functions may or may not use a control signal or control contact to start the timing function. Timing charts depict how each timing function is controlled and how the timing relay contacts act relative to the timer function. If a system contains a PLC or smart relay controller, the timing functions will be programmed in the controller. In some large motor starting applications, pneumatic timers may be used. These devices are mechanically attached to the motor starter and operate during the starting sequence. Thanks for watching.